In this video, I want to talk about solving an absolute value inequality. So solving an inequality involving an absolute value is a little bit harder than just solving an equation using an absolute value. We have to think again about what it actually means to have an inequality involving an absolute value. So let's start with something simple. The absolute value of x is less than 3. Now let's try to think about what this actually means on the number line. So the absolute value of x needs to be less than or equal to 3. So when we talk about the absolute value of something, it's only the positive part of that number. But it's also sometimes referred to as the distance away from 0. Because, for example, -3 and +3 have the same distance away from 0. So we need to think about the important players here. And so the important players here are going to be -3 and +3, right? We know that those are the numbers that are going to be involved. So if the absolute value of x is less than 3, that means that the absolute value of x could be 2, which would be around here somewhere. It could be 1, which would be around here somewhere. It could be 2.5, or it could be 2.87. It could be anything in there, or it could be inside the x part, inside the absolute value, could be something negative, right? It could be like -2 or -1 or -2.99, all the way up to -3, right? But not including -3. So we typically mark an open circle, or sometimes we would actually go ahead and mark a parentheses, just like we would in our interval notation. So an open circle at -3, and then any number in here is going to work, right? Any number in here is going to work all the way up till 3, and then we'll put another open circle at 3. So any number in here. So this is how we would graph the solution to this inequality on a number line. You also might see it done like this, and that's fine too. The open circle and the parentheses mean the same thing, and some people use the open circles on a graph, and other people just use the parentheses on a graph, and that's fine. So what this means is that the absolute value of x has to be between -3 and +3, right? Because it has to be less than 3. Now, if you had an absolute value that had to be greater than 3, so if let's actually have the absolute value of y needs to be greater than or equal to 4. So this is going to be a little bit different. So if the absolute value of something needs to be greater than 4, then let's go ahead and put 4 on our graph here. But if the absolute value needs to be greater than 4, then it could be 5 or 6 or 7 all the way up through infinity, right? And then this says greater than or equal to 4, so it could also be 4. And then there's a whole nother set of numbers over here that will also work, and that's the negative numbers. The negative numbers where the absolute value is greater than 4. So for example, -4 works, and -5 works, -6 and 7 and 8, and all the way up to infinity. So, if the absolute value of something is greater than something, it's going to give you 2 separate shaded regions where they each go off to infinity. If the absolute value of something is less than something, it's going to give you 1 region in between an area. Okay, now things get a little bit more complicated. So let me go ahead and erase this, and we'll do a couple of more complicated examples. So let's try the absolute value of x minus 3 is less than 6. Okay, so now we have to solve it. So we know that this means that the stuff inside the absolute value needs to be it needs to be between -6 and 6, or another way to say it is it needs to be less than 6 but greater than -6. There's two ways to write this, and I'll go ahead and show both of them. So you can write it as just one inequality that has 3 parts. So x minus 3 needs to be less than 6, and it also needs to be greater than -6. You can just kind of write it as this one long inequality. But you can also say that x minus 3 needs to be less than 6, and x minus 3 needs to be greater than -6. Either of those ways it works the same either way. Now, if you have it as just one long inequality, you can add 3 to all 3 parts. And then you'll get -3 is less than x, which is less than 9. So x is trapped in between -3 and 9. If you do it this way, you can add 3 to both sides here and get x is less than 9. And here you can add 3 to both sides and get x is less than -3. Like I said, either way works and it means the same thing. X is less than 9 and x is greater than -3 means the same thing as -3 is less than x, which is less than 9. In both cases, you would graph it. Whoops, didn't mean to do that. Let's see. Oh my goodness. Okay, that isn't even quite right. Let's see. Okay. All right. Yeah, still not even quite right. Okay. That's all right. So, how we would graph this would be that we just need to put -3 and we need to put 9 on our inequality. You don't really need to put in the other numbers. You can if you want to. So this is a strictly less than, which means we're not closing our circle. We're putting an open circle and shading in all the way up to 9, where we're going to put another open circle. And remember, another way to do this would be like this. So either one of these is an acceptable way to graph this inequality, which is the same as this one. X is less than 9 and x is less than 9. Oops, sorry, this should say x is greater than -3. Sorry about that. Okay, very good. So this should say x is greater than -3. And that's the same as it is over here. Okay, so let's do one more example, a little bit more complicated. So let me just get rid of all of this stuff. And let's try this example. Okay, so it says the absolute value of 2 minus x is greater than or equal to 1. So we know that a greater than means that we're going to have 2 separate regions in our inequality. One where it's greater than that number, so 2 minus x is greater than or equal to 1. But then we also have, again, think about this, think about your number line here. So whatever's inside that absolute value, it could be greater than or equal to 1 over here, or it could be less than or equal to -1 over here. So 2, this is an or, 2 minus x could be less than or equal to -1. Okay, so now we need to solve these inequalities. So here I'm going to go ahead and add or subtract 2 from both sides. Now there's more than one way to solve these inequalities. I'll do it one way and you can do it however you want as long as you get the same answer. So I'm going to subtract 2 from both sides and then I get negative x is greater than or equal to negative 1. Now I'm going to divide both sides by negative 1, but I'm going to remember that in an inequality, if I divide or multiply both sides by a negative number, I have to change the sign of the inequality. So x is going to be less than or equal to positive 1. So I divided by a negative number, which means I changed the greater than to a less than. Okay, or let's subtract 2 from both sides here. So negative x is less than or equal to negative 3, divide by negative 1. So x is greater than or equal to 3. So my result here is that x is less than or equal to 1, or x is greater than or equal to 3. So when I graph that on my number line, remember that I really only need a 1 and a 3. You don't really need to put in any other numbers, although you're welcome to. And then x is less than or equal to 1. So that would be, and I'll use the interval notation here, it's a bracket and then shade it in, or a bracket and shade in over here. Now a bracket is the same thing as a closed circle, so you could also use a closed circle like that. And either one of those is fine. So you don't need to do both like I just did, but either this closed circle or this with a bracket. Either one of those is fine, and they mean the same thing. And that's how we solve an absolute value inequality. Remember that it's a different procedure if x is if the absolute value stuff is greater than something versus if it's less than something. So make sure you watch that sign carefully.